Okay, so we're going to start a new chapter, and we're going to start the chapter on chemical reactions. So for this first part, we're just going to focus on writing chemical equations and just the basics of a chemical equation. For this video, you're going to want to have your periodic table out. So what is a chemical reaction? Well, a chemical reaction is just the process where one or more thing converts into a new thing or a new substance. And the important thing here is that it does have different properties. Okay? Some examples of these is when rusting occurs, or when we mix baking soda and vinegar, we have that fizzing action, or bonfires, or when plants are having respiration. They're making CO2 for us. So what are some signs that a chemical reaction has taken place? Well, we could have a change in temperature or light being emitted. We could have the production of a gas, like we were talking about those bubbles. You could have production of a precipitate. This is a word you're going to need to know. It is a big kind of word, but all it means is a solid, okay? Precipitate is a solid that's being formed from a reaction. You could have a change in odor, so if it smells different, or you could have a change in color. Just be careful on that, because we know, like we use food coloring in lab all the time just to make things fun. So obviously that is not a chemical change, but like rusting, that sort of thing, that color change is chemical. Okay, so here just general traits of chemical reactions. So we have reactants. Reactants are the substance that enter a chemical reaction. It's the stuff that you start with. So if you start with vinegar and baking soda at the beginning of a reaction and mix them together, those are the reactants. Products, that's pretty obvious, I think. Those are the substances that are produced or made in a chemical reaction. So in that vinegar and baking soda example, you would be making carbon dioxide, which would be your bubbles. Sodium acetate would be the white stuff left over, and water. So do all combinations result in a chemical reaction? Meaning anytime you mix something together, is that a chemical reaction? And I'm thinking that you guys should be able to answer this on your own and say no. And the reason why is because some things, when they're combined, they just form a mixture, like making Kool-Aid, brewing coffee or tea, that sort of thing. Okay, so in a chemical equation, this is just an expression that uses chemical symbols to represent the reaction. So this is just our way of showing what's going on. A chemical reaction represents the identities and relative amounts of the reactants and products. So it tells you what is in the reaction and how much of each thing is reacting. So we have word equations. So word equations are whenever you have in words what's going on. So acetic acid plus sodium bicarbonate yields carbon dioxide plus sodium acetate plus water. That would be the official way to say vinegar plus baking soda makes those products. And then you have a formula equation. So this would be the representation of that. And we're not going to get that fancy. That's pretty fancy. Okay, so you do need to know the symbols that are used in equations. And some of them are pretty easy, pretty self-explanatory, and some of them are a little more complicated. So you're going to have next to each thing in the chemical equation, whether it's a solid, liquid, or gas, or dissolved in water. And so a little s means solid, a little l means liquid, and a little g means gas. A little aq stands for aqueous, and that's just going to mean dissolved in water. Okay, you do need to know that. Now you're not going to have to draw it, but if you see an up arrow, that's going to indicate that a gas is formed. And if you see a down arrow, that's going to indicate that a solid precipitate is formed. Remember that word precipitate means solid. Okay, so the right arrow means produced or made or yields. You do need to know that word yields. You will hear it and see it. And just like if you are taking nutritional wellness or foods class and they say this recipe yields 2 dozen cookies, it means it makes that, okay? Sometimes you'll see an arrow going back and forth both directions. And that means exactly what you think it might mean. It means that reaction can go back and forth. The reactants can make the products, but the products can go back and make the reactants. Okay, so it can go both ways. Now, sometimes you're going to have your arrow and you're going to have stuff over the top of it. And that's going to mean that stuff is required to make that reaction happen. So if there's a triangle, then that's going to mean that there's heat applied. And sometimes instead of a triangle, they'll just use the word heat. They could use any number of things to make a reaction occur. And so if there's something else written over the arrow, that just means it's not part of the reaction, but it's used to make it happen faster. Okay, so we're going to write some equations now. So that's what this whole little section's about. Is I'm going to give you some words and some sentences, and you're going to have to write that into an actual chemical equation. And so there's a 3-step process you can use to do this. You don't have to use this process necessarily, but it kind of shows you a good way to do it. So here's an example. Sodium metal is added to water. Hydrogen gas bubbles off, and sodium hydroxide is left behind in solution. So the first kind of thing you want to do is think about what's there, what's going on. So the first thing it says is there's sodium metal. So we definitely have sodium is added to water, so that would be plus water, right? And so those are our reactants. That stuff's going to go on the left side, and then we can add an arrow. And then it says hydrogen gas bubbles off, so that's going to be released, so that's going to be a product. So we can write hydrogen, and it says and sodium hydroxide. So a little white and plus, and then sodium hydroxide. So then the step 2 would be to go ahead and translate this into formula. So this is probably the hardest part about this chapter, is remembering how to write your formulas. Now we just did this, it shouldn't be that hard, but this is the hardest part for people. So sodium is easy, right? Okay, Na. And then we leave our plus sign there. Water, we know what water is. Water is H2O. And we leave our arrow there. And hydrogen. So hydrogen, you may or may not remember, is a diatomic molecule. What does that mean? Well, it means that instead of writing just an H down, it's going to be a little 2 with it. Hydrogen never is by itself. It's always runs around in pairs. So there's our hydrogen. And we can add our plus sign there. And then sodium hydroxide. So you have to look up the formula for sodium, look up the formula for hydroxide, and switch the charges. So sodium is plus 1, hydroxide is minus 1, and then there you go. Okay, so this one wasn't hard because there weren't any hard charges to switch. Our last step there is to fill in all the symbols that tells us the state of the reactants. So let's read about sodium one more time. Sodium metal. Is metal a solid, liquid, or gas? Well, obviously a metal is a solid, right? I'm going to go ahead and copy that equation down. Okay, so obviously sodium's a metal. It says water. It doesn't tell us what water is, but water, I mean, obviously water's a liquid unless it tells us. I mean, they would say steam or they would say ice if it wasn't, right? Okay, and then hydrogen gas bubbles, so that would be a gas, right? And then sodium hydroxide is left behind in solution. So we have to think about, what does solution mean? And if you can think back to a long time ago, solution means it is a mixture. It's dissolved in water. So that would be aqueous. Okay? So that's as hard as it gets. So okay, real quick before you do one practice problem, let's review the diatomic elements. Okay, so we have hydrogen. We just talked about that. And then all you do is you find over here where nitrogen is, and it's a 7. So nitrogen, oxygen, fluorine, and then you go down to iodine. Those 7 elements right there, and hydrogen. And the way that my chemistry teacher in high school taught it to me is to remember it's Hofbrinkel. I still remember that, but I didn't need to remember that because I just remembered that it's hydrogen over here, and then nitrogen, oxygen, fluorine, and then down. Just this little group of 7 right here. Those guys always are diatomic. They always float around in pairs. Okay, so I'm going to give you one example, I'm going to give you one practice problem. I want you to try this one on your own. So see if you can write it out. Okay, so this one's fairly simple, right? It says hydrogen gas is added to oxygen gas to produce liquid water. So we have hydrogen added to oxygen to produce water. Okay. So equations. Hydrogen is H2 because it's diatomic. Oxygen is O2 because it's diatomic. And we know what water is. Easy peasy, right? Okay. So solid liquid gas is hydrogen gas, it says. Okay, we can handle that. Oxygen gas, so easy. And liquid water. I mean, that one was real straightforward. So, I mean, everyone should be able to get these straightforward ones, and then we'll have to work a little bit to get the harder ones, but we'll be able to get it.